Hello friends, welcome to interview preparation session by 360DG TMG. So I am going to ask you some questions on data science, and for each question I will be giving some time so that you can put your answers in your chat box, and then I will reveal the answer. Yeah. So our first question will be logistic regression is used for classification. Then why it is called as regression? Right? Logistic regression is used for classification. Then why it is called as regression? So that is your first question. Okay. So as we know, logistic regression is one of the basic and popular algorithms to solve a classification problem. It is named logistic regression because its underlying technique is quite the same as linear regression. So the term logistic is taken from the logic function that is used in this method of classification. Okay. So logistic regression is one of the basic and popular algorithms to solve a classification problem, but the underlying technique is quite the same as linear regression. And the term logistic is taken from the logic function that is used in this method of classification. Okay, friends? Okay. Now, moving to the second question. Explain correlation. So, what is correlation? If you know, you can put your answers in chat box. Okay. So, what is correlation? Correlation is used for measuring and also for estimating the quantitative relationship between two variables. And correlation measures how strongly two variables are related to each other. Okay. So we have examples like income and expenditure. In the same way, we can say demand and supply. So these both are correlated to each other. So when we have a data, so we look for a correlation, right? So correlation is used for measuring and also for estimating the quantitative relationship between two variables. Okay. And we have examples here, income and expenditure and demand and supply. Yes, relation between the independent variables. Yes, thank you. So, can logistic regression used for more than two classes? Can we use logistic regression for more than two classes? Is that possible? So as we have seen earlier, logistic regression is used for classification, right? So the question is, can we use logistic regression for more than two classes? So, yes, No, it's a binomial. Yes. No, by default, logistic regression is a binary classifier. So it cannot be applied to more than two classes. Okay. However, it can be extended for solving multi-class classification problems. So that is multinomial logistic regression. Okay. So the answer is, the question was, can we use logistic regression for more than two classes? And the answer is no. By default, logistic regression is a binary classifier, so it cannot be applied to more than two classes. However, it can be extended for solving multi-class classification problems, which is known as multinomial logistic regression. Yes, Rohit, we can use. Yes. We can use it when we are solving multi-class classification problems. So it is multinomial logistic regression. Okay. But by default, logistic regression is binary classifier. So your next question is, what is true negative? So what is true negative? Any answers? Okay, when a model correctly predicts the negative class, it is said to be a true negative value. Okay, so when we are predicting something and our model correctly predicts the negative class, it is said to be true negative. Yeah, model correctly predicts the negative class. Yes. And for example, here we have given something like umpire gives a batsman out when he is out. Yes, right? If not, we will have a review again and it may change also. So, your next question is, what is evaluation metrics for classification? What is evaluation metrics for classification? Any answers, friends? So the question was, what is evaluation metrics for classification? So the answer is, so we have metrics like accuracy, precision, recall are the good ways to evaluate classification models. Yes, precision, accuracy. Yes, Rohit. So we have metrics like accuracy, precision, recall, which are good ways to evaluate classification models for balanced data sets. But if the data is imbalanced, then we have other methods like ROC or AUC. Okay. So which is nothing but receiver operating characteristic curve, or we use area under the curve. Okay. Perform, which gives the, which is used for evaluating the model performance, right? So these metrics are used for evaluating the model performance. Okay. So your next question is, yeah. So evaluation metrics for regression. So we have seen what are the evaluation metrics for classification. Now, what are the evaluation metrics for regression? So what are the evaluation metrics for regression? So the question was, what are the evaluation metrics for regression? We have seen what are the evaluation metrics for classification. So we have accuracy, precision, recall, which are good ways to evaluate classification model. But in case of, if the data is imbalanced, we use ROC or AUC. But now the question is, what are the evaluation metrics for regression? So the answer is, okay. So we have three error metrics. Yes, Supravit. RMSC, MSC. Yeah. So we have one more, right? Mean absolute error also. So there are three error metrics that are commonly used for evaluating and reporting the performance of a regression model. So what are they? Mean squared error, root mean squared error, and mean absolute error. Okay. So what are the evaluation metrics for regression? So we have three error metrics for evaluating and reporting the performance of regression model. And what are they? Mean squared error, root mean squared error, and mean absolute error. Okay. So your next question is, what do you understand by outliers? So we have outliers in our data, right? So what do you understand by outliers? Any answers, friends? It's an easy question, right? What do you understand by outliers? Yes, question. Extreme negative or positive values. Extreme values, right? When we have the extreme values in our data. So, an outlier is an extremely high or extremely low data point relative to the nearest data point and the rest of the neighboring coexisting values in a data graph or data set you are working with. Okay. So in simple, outliers are extreme values that stand out greatly from the overall pattern of values in a data set. Okay. So outliers are extreme values that stand out greatly from the overall pattern of values in a data set or graph. Yeah, we can say that below the lower limit and above the upper limit in IQR plot. Yes, when we have box plot. So your next question is, what is trimming? So, any answers, friends? What is trimming? So we have seen what are outliers in our previous question. So now the question is, what is trimming? Okay. So trimming is trimming data excludes the outlier values from your analysis. Okay. So what we do? We do trimming, exclude the outlier values from when we are doing our data analysis. Okay. So trimming is a process that excludes the outlier values from the data which we are analyzing. Okay. So the next question is, what is vinsorization? Any answers, friends? So vinsorization is a process of, okay, any idea what is vinsorization? So it is a term related to outliers. Okay. So vinsorization is a method of averaging that averaging the initially replaced the smallest and largest values that are outliers, right? With the observed observed and closest values to them. Okay, so this is done to limit the effect of outliers or abnormal extreme values or outliers on the calculation. Okay. So vinsorization is a way to minimize the influence of outliers in your data. Okay. So it will be done either by assigning the outlier to a lower weight or by changing the value so that it is close to other values in the set. Okay. So your next question is difference between trimming and visualization. So we have seen the both techniques, right? So both techniques are related to outliers. Okay. So what is the difference between trimming and visualization? So trimming and vinsorizing are two ways to migrate the effect of extreme values on your analysis. Okay. So trimming data excludes the outlier values that we have seen earlier, right? What does trimming does? It excludes the outlier values in our data analysis. But in case of vinsorizing, it retains the responses in your basis, but the numeric outliers, so they fall all the edge of the main distribution. So what we have seen earlier, visualization is a way to minimize the influence of outliers. How it does? Assigning the outlier to lower weight, changing the value so that it is close to the other value. So we are not trimming here. Okay, we are doing a process to retain the value, but we are doing something like we are assigning the outlier to a lower weight, or we are changing the value so that it is close to other values in the set. Okay, but in trimming we are directly excluding the outliers. Okay. So the next question is, we have seen true negative, right? So what is true positive? So what is true positive? Yes, Roshan. Trimming deletes the data from data set. Inspiration replace the outlier with another one. Yes, Vaibhav. Your answer is also correct. Yes. Yeah. So when the prediction is true, right? And it is correct. So when a model correctly predicts the positive class, it is said to be a true positive. Okay. So see here we have the same. Umpire gives not out when he is not out. So that's a simple one, right? So we have seen what is true negative, and now we have seen what is true positive. Okay. So describe the dimension reduction in machine learning. Okay. So the next question is describe dimension reduction in machine learning. Yes, Venki and Divya, yes. Predicted and actual both are positive. Model predict the true and positive class. Yes. So your next question is describe dimension reduction in machine learning. Yeah. So Prabhat says reduce the columns. Yes. Let's see. So dimension reduction is a process which is used to reduce the number of random variables under considerations. So dimension reduction can be divided into feature selection and extraction. Yes. So dimension reduction is the process which is used to reduce the number of random variables under considerations. And dimension reduction can be divided into feature selection and extraction. Yeah, reduce the columns PCA. Yes. So, yeah. So the next question is, what is false positive? So your next question is, what is false positive? So we have seen, right? We have seen true negative, true positive. Now we have a question. What is false positive? So Prabhat says prediction is true and actual is false. Yeah. When a model incorrectly predicts the positive class, it is said to be false positive. It is also known as type 1 error. Okay. So we have an example here. So umpire gives a batsman not out, but he is out. So when a model incorrectly predicts the positive class, it is said to be a false positive. It is also known as type 1 error. So that is false positive. Okay, so let's move to the next question. Okay, let's close this with false negative. So we have all these categories, right? We have seen true negative, true positive, false positive, and now we have what is false negative. So the answer is when a model incorrectly predicts the negative class, it is said to be false negative. It is also known as type 2 error. For example, umpire gives batsman out when he is not out. So your next question is, how do you calculate accuracy in classification using confusion matrix? So how do you calculate accuracy in classification using confusion matrix? Any answers, friends? So the question was, how do you calculate accuracy in classification using confusion matrix? Okay. By dividing the number of correct predictions by total number of predictions. So, how do we calculate accuracy in classification using confusion matrix? By dividing the number of correct predictions by the total number of predictions. Yes. Yes, when key support. Yes, that's right. Okay. So the question was, how do you calculate accuracy in classification using confusion matrix? And the answer is by dividing the number of correct predictions by the total number of predictions. And we have the formula here. Okay. So what it does, it gives you the overall accuracy of the model. Okay. So the accuracy is equal to true positive plus true negative, and that is divided by all factors. So true positive, true negative, false positive, and false negative. Okay. So that gives us the accuracy, overall accuracy of the model. So your next question is, what are L1 and L2 regression also called as? So L1 and L2 regression also called as okay. So L1 regularization technique is called lasso regression, and model which uses L2 is called ridge regression. Yes, yes, Vaibhav. Yeah, lasso and ridge, right? So L1 regression technique is called lasso regression, and model which uses L2 is called ridge regression. The key difference between these two is the penalty. So your next question is, what is R2 and adjusted R2? And which is more reliable? So the question is, what is R2 and adjusted R2? Which is more reliable? Any answers, friends? So I'm repeating the question again. What is R2 and adjusted R2? Which is more reliable? So it is also called as the coefficient of determination, and R square measures the proportion of the variation in your dependent variable explained by your independent variables for a linear regression model. And the adjusted R squared adjusts the statistic based on the number of independent variables in the model. Okay. And R2 don't penalize, but adjusted R square will. Sorry. So what is discriminant Q? So any answers, friends? What is crisp MLQ? Yes. It is a cross industry standard process for machine learning applications. Okay. What do you have now? With quality assurance, right? So before it was risk DM, right? For data mining. So what are three different measures of central tendency? So your next question is, what are three different measures of central tendency? Yes. They are nothing but mean, median, mode. Right? So the next question is, what are three different measures of dispersion? So what are three different measures of dispersion? So the three different measures of dispersion are variance, standard deviation, and range. So your next question is, explain moments of business in statistics. So explain moments of business in statistics. So yeah, we have four moments of business. Moments are a set of statistical parameters to measure a distribution. Okay. So we have four moments are commonly used. The first moment of business is mean, the average. The second moment of business is variance. And the third moment of business is skewness. And the fourth moment of business is kurtosis. Okay. So your next question is name few classification. So name few classification algorithms used in machine learning. Base, KNN, yes. So some common classification algorithms we have are linear classifiers, SVM, data trees, KNN, and random forest. Okay. So your next question is list few unsupervised learning models. So list few unsupervised learning models. Okay, so we have clustering models, hierarchical clustering and k-means clustering. We have PCA, principal component analysis, recommendation system, association rules, network analytics, and text mining, right? So these are different unsupervised learning models. Yes. Yes, Divya, yes. NLP. So your next question is what is reinforcement learning? So it's a type of learning, right? So Any answer, friends? What is reinforcement learning? Let's see. So it is an area of machine learning which is about taking suitable action to maximum reward in particular situation. So we use this in gaming. Okay, reinforcement learning is used in gaming processes. Friends, last question for the day. So, what is semi-supervised learning? So, what is semi-supervised learning? So, it is an algorithm which is trained upon a combination of labeled and unlabeled data. Typically, this combination will contain a very small amount of labeled data and very large amount of unlabeled data. Okay, so that is semi-supervised learning. Okay, so thank you, friends. So this is it for today's interview preparation session, and let's meet in the next session. Thank you.